if I'm doing this very first one, this is from your homework. Like you said, there's a 2 that's in common. So that's my first common factor. And if I go to the R, this one has 4 R's. This has 3, but this only has 1. So if this only has 1, you can only have one common factor of R between all the terms. So I will only have just 2R as the GCF, or the greatest common factor. And then I'm going to factor out, if I factor out the 2R, I need to write what's left. So then 2R times what will give me 2R to the 4th? Well, R cubed. Okay, because R cubed times 2R will give me that term. Then I go to the next one. So 2R times what would give me 24R cubed? Well, if I start with the numbers, 2 times what is 24? 12. And then R times what is R cubed? How many more R's do I need to multiply? 2 more. So R squared. Okay, and then the last one, 2 times what is 40? 20. Okay, R times what is R? Or do I need to multiply any R's? No, I don't, because I already have 1 R in this term, and there's already 1 R here. So 2R times 20 is 40R. So, and just double check it, like check each one. Does 2 times this, does 2R times this, give me that. Does this times that, give me that. Okay, go through each one, double check it. All right, and then after that, you may have to do a second step of factoring. Okay, so that was what we looked at yesterday, was like, for instance, on this one down here, first I had to find the greatest common factor, and then I had to factor with the diamond. Okay, or maybe the box, depending on what kind of problem you have. So sometimes you do one step and sometimes you do 2. Okay. All right, so let's just keep that in mind as we work through these. So first, just remember that we are factoring. And then, by the way, if you guys in here want to use highlighters, I have some over there if you guys want to borrow some, okay? Now, the key thing with this, as Ms. Menard will point out, is that this is a shortcut. Now, you could use the diamond to factor this out, but this is a shortcut. And the reason it's a shortcut is because it's like a unique situation where I have one perfect square here and one perfect square here. And remember, a perfect square is just like a perfect square is a number that I can square root and it'll give me a whole number, right? The square root of 16 is 4. Square root of 49, 7. Okay, so that means they're perfect squares. So if I have let's say a perfect, oops, that's a perfect square minus another perfect square. And remember, it has to be minus. In order for this to work, it has to be minus. If I have one perfect square minus another perfect square, then I can go straight to the factors, okay? And the way I do that is I'm just basically going to square root the first number. That's going to be my first term. So step 1, square root each term or each number. So square root each number. So what I'm going to do here is I'm going to square root 16. 16m squared. So the square root of 16 is 4. And the square root of m squared is just m. Okay, that ends up being my first term in each of these parentheses. And then I do the same thing with the second number. I square root that. and now I get 7. And that ends up being the second term in each of these. Now, inside the parentheses, the signs will always be the same with this type of problem. It will always be, one will be plus and the other will be minus. Okay, so then step 2 is the first term goes first. In other words, the 4m, this first term goes first in each of one. So first term goes first, and then second term is second. So I take the square root of the second one, and it's the second number. And then will always be plus and minus. Okay, you always have one will be plus and one will be minus. So that's what I just wrote right there. Okay, so show that one more time. Let's actually look at it like, let's do 8. We're gonna do 8x to the, let's say to the 4th, plus, let's do 32 x squared. Okay, now if I'm looking at 8 and 32, those are not perfect squares. Okay, I can't take the square root of 8 and get a whole number. But what I do notice, like I said before, is check to see if there's a common factor. Okay, so the common factor in this number and this number would be, let's see. Actually, I don't want it. Divide by 2. Hang on. Sorry, guys. I don't want it to be that. Okay, change this number to, let's say, 50 instead. So instead of 32, let's put 50. Okay, so the common factor between 8 and 50, yeah, 2. And then if I'm looking at the x variable, they both have at least 2 x's, so I put 2x squared as my common factor. Okay, so now I divide this by 2, or 2 times 4. Okay, and then x squared times x squared would give me x to the 4th. And then here again, 2 times 25. And x squared, if I don't need to add in another x here because 2x squared times 25 is 50x squared. Okay. I apologize, I made one more mistake, my bad. Okay, this has to be, what sign does this have to be in order for this to work? It has to be a negative. Okay, so that has to be minus. Okay, so now, again, what we did is we factored out the common factor. Then what I need to do is look right here and say, can I factor this second part any further? Well, if you notice, the 4 is a perfect square and the 25 is a perfect square. So I can factor it just like I did this one up here. I'm going to square root the 4x squared. So square root of 4 is 2x. And remember it's the first term, just like here. I squared root the 16. I got 4m, 4m. I squared the 4x squared, 2x, 2x. What's the second term? 5, because I'm basically doing the square root of 25. So here, we'll say that we square root the terms. And then what signs do we always have when we do perfect squares? Plus and minus. Okay. So I did that. So I did the difference of squares, but first I had to factor out that common factor. Okay, so next example I want to look at is this is differences of two squares, and then the other one that you might see is I'm looking at, so like if I'm looking at the worksheet, that would be this problem, number 1, number 2. Okay, if you look at this one, that one also is probably going to end up being the same thing, but I want to factor out a common factor first. So common factor between these two numbers would be 5. So if I factor out 5, then I get 4x squared minus 5 divided by 125 divided by 5 is 25. And now you can see I've got those perfect squares. So now the next step would be to square root these terms and then write them in here, okay? So again, that's straight from your packet. And then this one's just like those as well, okay? Those are already 2 perfect squares there. The next one would be, if you notice, that's not a square anymore. It's not an even exponent, it's a cube, okay? It's a cube, it's cubed, so that means we're gonna have to use a different method. So we're gonna do this example right here, 64x cubed plus 27. So 64x cubed plus 27. So this is going to be a difference of cubes. Now the formulas that you're going to use, there's a formula that you need to set up for these. And if you have a perfect cube plus another perfect cube, then what you're going to, when you factor it, what you're going to end up with is A plus B, and I'll show you how to find A, times A squared minus A times B plus B squared. Okay, again, that's if you're adding. Now, let's say that this number is actually minus, because it doesn't matter if it's plus or minus. You could still factor it. But if that's minus instead, let's say it's a perfect cube minus another perfect cube, then this pretty much looks the same, but the signs will change. The first one, instead of being A plus B, it'll be A minus B. And then the second part of the factor, you'll have A squared plus AB. But then the last sign stays the same. It'll still be plus B squared. Okay, so the first thing you got to do is find A and B. Your A comes from your first term, your B comes from your second term, all right? And just like I did up here where I square rooted the first and last term, instead of square rooting, I'm going to cube root, okay? Cube root these two terms. All right, so to find A is going to be equal to the cube root of the first term, so that's a 3 up there, of 64x cubed, and B will be the same. It'll be the cube root of 27. Now, if you guys know your cube roots, like what number do you multiply 3 times to get those, then great. If you don't, you can always use Desmos. So if I go to Desmos, and if you guys look right here, you have square root, but then you'll have this other root function, okay, where you can do cube roots or fourth roots. So I hit the cube root, and then now I can't do 64x. Like, it's not going to tell me what x cubed is. Okay, I can't do like that. It's going to give me an error, but I can find out what the cube root of 64 is, which is 4, because 4 times 4 times 4 is 64. Okay, and then I also need to know the cube root of 27, which is 3. Okay, so now for the first term for A, it's 4, but I'm also taking the cube root of x cubed, which is just x. Okay, and then B will be just 3 because there's no x, there's no variable there. All right, so now all I have to do is once I find the A and the B, I just plug it into the formula. Now remember, this one's plus, so I'm going to use the first formula, the sum. Okay, so it will be A, which is 4x, plus B, which is 3. And then you can see it says A squared. So that means I'm going to take the A and square it. I'm actually going to write it in here just so you can see like where this comes from. And then the first sign inside here will be minus, and then it's A times B. Actually, let me give this a little bit more room. This next one will be A times B, and then plus B squared, so 3 squared. Make this a little clearer here. So that's 4x squared. So here I want to, now you guys don't have to write this all out. I'm just kind of showing you where these numbers are coming from. You can go ahead and write the terms right away. If you know what 4x squared is, then go ahead and do that. So here, nothing changes here. But here I had to square 4x. So 4x times 4x. So 4 times 4 is 16. And then x squared. And then here, it's negative 4 times 3, or negative 4x times 3, which is minus 12x. And then the last one is 3 squared, which is 9. Now, when you do these, this last part might look like you can factor it even further, but because of the way that these problems are designed, you won't be able to factor that. So I can't set this up with the box and factor 16x squared minus 12x plus 9. Okay, so that's going to be pretty much it for those differences of cubes. Now remember, if it's a minus to start with, the only thing that changes is now I'm going to put minus here instead. Minus in the first parenthesis, so it would have been like 4x minus 3. And then here it would have been plus instead of minus. So that's the only thing that changes if it's negative, okay? Okay, any questions on that one so far? Let's see. Okay, we'll just do one more. Now remember, with these, you may have to do GCF first, okay? So for example, you guys don't have to take notes on this one. Let me pause it. So example for number 10, basically I would need to factor out 2, and then I would need to find the cube root of those two numbers and then plug it into the formula, okay? And let's see. Okay, I think that's it for you guys that are online. You guys have any more questions about this week, next week, about what we went over? All right, you guys are online. If you're not in class tomorrow, I will see you guys at the same time tomorrow. Again, I'll post this recording later. All right, you guys have a good morning, good day. See y'all tomorrow.